Assalamualaikum warahmatullahi wabarakatuh, and good day again, everyone. So now, let's continue a little bit more on shear strength. So we're now in part 2. Okay, so part 2, inshallah, we will be discuss on the direct shear strength or shear box strength test method in order to determine the parameters. In order to determine the shear strength parameter. So we already agree that there are two important shear strength parameter, which is C and also phi. Okay, either C and phi in the total condition, or C prime and phi prime. Okay, C prime and phi prime, internal friction angle in the effective stress condition, and cohesion in the effective stress condition. Or C and also phi. So this is in the total stress condition. So let's see. We know that actually there is in total few different ways to determine the parameters. Okay. If I could show you, okay, this is the division. The test that we have, laboratory test and also field test. So in this part 2, we will discuss on direct shear test. But nonetheless, we also have a field test. So we can have either wind shear test, torr wind, and so on. But in this course, we only focus on the wind shear test. Okay, so let's see a few scenario. Okay, a scenario. So we know soil sample at certain condition, at certain depth, that we want to check their shear strength is usually retrieved from the borehole or bore activity. Okay, we excavate using a bore and borehole, and we record the bore sample. So sample usually comes in the cylinder, and from here we can see that the original soil condition or the sample condition is applied with a few types of pressure or stress. So horizontal confined stress and also vertical confined stress. So that's why when we want to bring the soil into laboratory, we also need to simulate the field condition in the laboratory test. Okay, so this is condition with the green field without any building. Okay, so green field condition without any building. So of course, at the certain depth, the soil sample is only have a original stress from the vertical confined stress. But if we have a building, so we have a structure. So of course we have a foundation here, foundation footing maybe. So here comes the differences. Okay, the difference is we have the deviator stress or delta stress. Deviator stress, which come from the loading Q, or sometimes Q, or sometimes P, loading, for external loading. So delta stress. If you learn more in geotechnics 1 letter, delta stress or the deviator stress can be defined using several types of method, namely FADM, 2-to-1 methods, Bosinex, and Westergaard, and so on. But in our course for soil mechanic, we only take the value. Okay, we only take the loading value. Alright, so when we want to bring the soil sample from the field into the laboratory, we need to simulate. Okay, we need to simulate here, simulating the field condition, because we already have zero value when we take out the soil sample from the field. So now we lost the confined pressure. Okay, confined pressure. So that's why in the laboratory we need to prepare the specimen. Okay, prepare the specimen and then apply the initial stress condition. In the different setting manner. So in the triaxial, this is the representation of the soil sample. Usually we have a cylinder type, and we doesn't design the failure line. We just take the soil sample, apply the load vertically, horizontally. If we have a horizontal load, confined pressure load, and we get the failure line. In the direct shear test, it is different. The soil test or the apparatus of the direct shear test is designed with the failure line. We have the designated failure line, but still we apply the load, but differently. We have a in the direct shear test is quite different compared to the triaxial. So we have here tau or shear strength, and we also have a vertical confined load or stress. Okay. So of course the laboratory test is used to define the parameters. So let's see for the direct shear test first. Okay, so this is one of the direct shear tests we have in the laboratory, quite old. So if we look more further to the machine, so here is the shear box. Here is the shear box. Some probing ring to apply the shear strength, loading system, and dial gauge to read the vertical displacement, horizontal displacement. So let's see shear box. Okay, loading frame. Okay. Dial gauge to measure the vertical displacement. Similarly, we have another dial gauge to measure the horizontal displacement. Okay, horizontal displacement, and probing ring to measure the shear force that we apply. Okay, tau that we apply. So let's go through a little bit on the shear test procedure. Of course, we need to set up all the basic one first, and then once ready, we pour the soil into the box, the shear box, and cover it with the porous steel at the top and bottom to allow dissipation of water if we have a water in the soil. And last but not least, we close the lid and apply the pressure plate, apply the loading. Right. Okay. So let's see more. Alright. So first step, just now we apply the vertical load and wait for the consolidation if we have a saturated soil sample of sand soil sample. And secondly, once the consolidation is stable, we apply the lower box, the tau, the shear strength. Okay. So the direct shear is most suitable for the consolidated drain test. Okay, and this is some figures in more details. What we have for the direct shear test preparation. So this is the box, porous steel. Okay, porous plates, the lid. Okay, and screws to close the lids and so on. And this is the sand is in the box, so make sure we level the top surface and close with the porous plate and also the lid. And once we start the test, we will get few data. First, stress normal and also the shear stress. So note that we need to plot the graph from the displacement, shear displacement. We can plot the shear displacement versus the shear stress. Okay, we can have a tau from the normal stress results. So let's say we do the test for 3 times, so we can have a sample 1, stress 1 results, stress 2 results, and stress 3. Okay, so at the maximum of the normal stress 1 is the first results here. So if you have a sample results, second results, so we have another tau at failure at 2, so we can plot another results in the graph of tau at failure versus the normal stress. And similarly, we redo for the third sample. Okay, third sample. And from here we can get the more Coulomb failure envelope, more Coulomb failure envelope, the failure line, and we can obtain the angle of friction, internal friction angle of the soil. So that is the parameters of our soil. If we do for the clays, the horizontal displacement should be applied at very slow rate because we need to allow the dissipation of water pressure, dissipation of the pore water pressure. So sometimes the direct shear test for the clay soil will take a few days to finish because we have a very slow dissipation of water. And similarly, we can have the failure envelope for the clay from the direct shear test. Still, the NC clay predict the failure line that cross to the origin of the graph, so we can get the internal friction angle for the clay. But for the over consolidated clay, where the C is not equal to 0, so we will have a value of C, and in the same time we also have the value of phi. Okay. So this is also some information for the shear displacement and shear stress plotting for the dense sand and over consolidated clay is like this. And when we plot the expansion and the compression of the soil sample, it will be like this. And if we have a loose sand or normal consolidated clay, so we will have another type of curve. Alright, in many foundation design problems, such as including the retaining wall problems, so it is very important to determine the angle of internal friction because we want to understand the interaction for soil and also the foundation materials. So if we design wrongly, okay, we might have a failure that that comes from the man-made wrongly judgment. So that's why we need to check for the C and phi. Okay, check for the C and phi. Alright, so this is some advantage of using direct shear, and this is also the disadvantage. But the most important is the parameter that we want to find in the sand is the phi. And this is one quiz with the answer, so you can try to solve the problems using graphical or analytical, and later we can have a discussion for this quiz. So I think I stop here for part 2, and see you next in the next video. So assalamualaikum warahmatullahi wabarakatuh and goodbye.